Okay, good morning. My name is Dominic and I am going to report about image processing application. An image is a picture, a photograph. It's visual data, and this usually an two-dimensional and three-dimensional info. What is a digital image? A digital image is an image which is discretized, defined on a discrete grid. Two-dimensional collection of light intensity value. And it has a matrix of two-dimensional function. What is digital image processing? It improves picture information for better clarity. And automatic machine processing of scene data. It's an interpretation by a machine, non-human storage transmission. I have here the important steps on a typical image processing system. The number one step in a typical image processing system is image acquisition. In image acquisition, here we capture visual data and we use an image sensor. We have different types of image sensors like UV, infrared, and so on and so forth. I will discuss it later on. Next is discretization or digitization. In this step, we will convert data into discrete form and compress to efficient storage transmission. The next step is image enhancement and restoration. Here in image enhancement restoration, we improve the image quality. Like if it has low contrast or it has a blur part, we will try to improve any way possible. Next step is image segmentation. In image segmentation, partition image into objects or constituent parts. Next step is feature selection. In this step, we extract pertinent features from an image that are important for differentiating one class of objects from another. Next step is image representation. In this step, we assign labels to an object based on information provided by the descriptors. And the last step is image interpretation. In this step, we assign meaning to an ensemble of recognized objects. Now let's move on to digital image processing. What is digital image processing? Since digital image processing has very wide applications and almost all of the technical fields are impacted by DIP, we will just discuss some of the major applications of DIP. Digital image processing is not just limited to adjust the spatial resolution of the everyday images captured by the camera. It is not just limited to increase the brightness of the photo, etc. Rather, it is far more than that. Electromagnetic waves can be thought of as a stream of particles where each particle is moving with the speed of light. Each particle contains a bundle of energy. This bundle of energy is called a photon. Okay, the electromagnetic spectrum according to the energy of photon is shown below. In this electromagnetic spectrum, we are only able to see visible spectrum. Visible spectrum mainly includes 7 different colors that are commonly termed as VIV-JOIRI, or as we all know it, RGB. In RGB, we have red, orange, yellow, green, blue, indigo, and violet. But that does not nullify the existence of other stuff in the spectrum. Our human eye can only see the visible portion, in which we saw all the objects. But the camera can see the other things that a naked eye is unable to see. For example, X-rays, gamma rays, and etc. Hence, the analysis of all that stuff too is done in digital image processing. This discussion leads to another question, which is, why do we need to analyze all that other stuff in EM spectrum too? The answer to this question lies in the fact, because that other stuff such as X-ray has been widely used in the field of medical. The analysis of gamma ray is necessary because it is used widely in nuclear medicine and astronomical observation. Same goes with the rest of the things in EM spectrum. Okay, Here I will discuss the different types of applications that have been used in digital image processing, and here is the list. Some of the major fields in which digital image processing is widely used are mentioned aside. Number 1 is image sharpening and restoration. Number 2, in the medical field. Number 3, remote sensing. Number 4, transmission and encoding. Number 5, machine-robot vision. Number 6, color processing. Number 7, pattern recognition. Number 8, video processing. And number 9, microscopic imaging. Now let's get into image restoration and sharpening. Image sharpening and restoration refers here to process images that have been captured from the modern camera to make them a better image or to manipulate those images in a way to achieve desired result. It refers to do what Photoshop usually does. So dito, matidiscuss natin na kung meron tayong picture ng mga lola natin and medyo matagal na yon, pwede natin yun mukhang paging i-modernize. So gagamitin na natin yung app na tawag is Photoshop. Sa Photoshop, pwede nating ma-restore yung kulay ng mga dating damit nila, lahat ng mga furnitures nila. Yan. Moving on, in image sharpening and restoration, this includes zooming, blurring, sharpening, grayscale to color conversion, detecting edges, and vice versa. Image retrieval and image recognition, the common examples are: number 1, the original image. Number 2, the zoomed image. Number 3, the blur image. Number 4, the sharp image. Number 5, edges. Medical field. Dito pinakagamit na gamit yung digital image processing. Okay. The examples are gamma ray imaging, PET scan, X-ray imaging, medical CT, and UV imaging. Now let's get into gamma ray imaging. Gamma ray imaging is used in many applications like nuclear medicine and astronomy. PET scan, positron emission tomography, is commonly used in medical diagnostic imaging. Radioactive isotope administered to patient which emits positrons. Positron and electron meet and annihilate, giving out gamma rays, which are detected by sensors. Prominent bright spots indicate white masses corresponding to tumors in lung and brain. Positron emission tomography. Here is the PET scan. Positron emission tomography imaging systems constructs 3D medical images by detecting gamma rays emitted when certain radioactively doped sugars are injected into a patient. Once ingested, these doped sugars are absorbed by tissues with higher levels of activity metabolism. Examples are active tumors than the rest of the body. The next is X-ray imaging. We are all familiar with X-ray imaging. X-ray imaging is used in a number of areas like medical diagnostics, astronomy, and industrial applications. X-rays generated by an X-ray tube, vacuum tube, pass through the object to be imaged and is then captured by a sensor. If an X-ray film is used as the sensor, it is typically digitized to get a digital image. Alternatively, the X-rays are captured by devices that convert it into light energy, which is then sent to a light-sensitive digitizing system. Next is UV imaging. In the field of remote sensing, the area of the Earth is scanned by a satellite or form of very high ground, and then it is analyzed to obtain information about it. One particular application of digital image processing in the field of remote sensing is to detect infrastructure damages caused by an earthquake. As it takes longer time to grasp damage, even if serious damages are focused on. Since the area affected by the earthquake is sometimes so wide that it is not possible to examine it with the human eye in order to estimate damages. Even if it is, then it is very hectic and time-consuming procedure. So a solution to this is found in digital image processing. An image of the infected area is captured from the above ground, and then it is analyzed to detect the various types of damage done by the earthquake. The key steps include in the analysis are: number 1, the extraction of edges, and number 2, analysis and enhancement of various types of edges. We move on to the next field, which is transmission and encoding. The very first image that has been transmitted over wire was from London to New York via submarine cable. The picture that was sent is shown below. Now just imagine that today we are able to see the video feed live or live CCTV footage with just a delay of seconds. It means that a lot of work has been done in this field too. This field does not only focus on transmission but also on encoding. Many different formats have been developed for high or low bandwidth to encode photos and then stream it over to the internet. Next field is machine-robot vision. Apart from the many challenges a robot faces today, one of the biggest challenges still is to increase the vision of the robot. Make robot able to see things, identify them, identify the hurdles, etc. Much work has been contributed by this field, and a complete other field of computer vision has been introduced to work on it. A very good example here is the bombing robot. Kaya niya po mag-detect ng wires na kailangan niyang putulin or gupitin in order to not detonate the bomb but to defuse it. Okay, hurdle detection. Hurdle detection is one of the common tasks that has been done through image processing. By identifying type of objects in the image and then calculating the distance between robot and hurdles. So ito yung makikita nating sensor ng mga sasakyan. Pagka kuwari nagbabaking tayo or kaya meron sa harap natin, lalabas sila ng alarm or kaya nang magtutulog yung sensor nila, which it means na malapit na tayo dun sa object natin or meron tayong malapit na obstacle na makihit. Kaya tawag na hurdle detection. Next field is line follower robot. Most of the robots today work by following line and thus are called line follower robots. This helps a robot to move on its path and perform some tasks. This has also been achieved through image processing. Next field is color processing. Color processing includes processing of colored images and different colored spaces that are used. For example, red, green, blue color model, YCVCR, HSV. It is also involves studying transmission, storage, and encoding of this color imaging. Next field is pattern recognition. Pattern recognition involves study from image processing and from various other fields that includes machine learning. In pattern recognition, image processing is used for identifying the objects in an image, and then machine learning is used to train the system for the change in pattern. Pattern recognition is used in computer-aided diagnosis, recognition of handwriting, and recognition of image, etc. Next is video processing. A video is nothing but just the very fast movement of pictures. The quality of the video depends on the number of frames, pictures per minute, and the quality of each frame being used. Video processing involves noise reduction, detail enhancement, motion detection, frame rate conversion, aspect ratio conversion, and color space conversion. That will be all. Thank you.